Hi, my name's Jeff Dean, and I'm Math Dad. I'm here to help you help your kids understand math. I get asked all the time about different ways in which people try to solve math problems. And a lot of times people say, why don't we just teach kids the way that I learned? Why don't we just teach them one way so that we all do the same thing? Isn't that easier? And the answer is kind of complicated because, in a sense, as a teacher, it might be easier to only show one way to solve a math problem. However, if everybody is only doing things one way, I eliminate the opportunity for people to do their own thinking. And then I don't know how well people really understand the math versus can follow a bunch of steps. So today we're talking about developing flexible thinkers. And one of the best ways to help our kids become flexible thinkers is for us as adults to become flexible thinkers ourselves. And here's what I'm talking about. When you see a math problem, do you think of only one way to solve it? When someone solves it a different way, does it make you go, wow, that's not how I would have thought about it. That's interesting. Let me see if that makes sense to me. And when we do that, suddenly we start to develop tools that we can put in our toolbox. So when we come across a problem, we can start making the decision like, which way is the best way to solve this problem? Because the standard way that we learned when we were in elementary school, although it will always get an answer, it is not always the quickest or most efficient way of solving a problem. And when we become flexible thinkers, we can be open to new ways and start to see other ways that people think about things so that we can think about things a lot differently and start to make a lot more sense out of math. Because one of the reasons why our kids sometimes struggle with math is because they don't have good number sense. And when all they're doing is following a list of steps to get to an answer, they're not developing number sense. They're just developing steps. And if they can't make connections on their own to what's really going on in the bigger picture of math, they're just stuck with steps. And if they forget a step, they have no access to the problem. But when we help them to develop their own strategies and become flexible thinkers, they can problem solve their way out of any problem that they may come across. Let's take a look at some examples of what I'm talking about. Here's situation number one. The other day, I was driving in the car with my wife and one of my daughters. And my daughter was so excited because she's starting to get her first paychecks. She was so proud because she worked 32 hours on the current pay period, which is the most that she'd ever worked. And I asked her, so how much money are you going to get? And she said, well, I make $12 an hour. So, really quickly, we all thought about how much money that is. And here's what I said. I said, okay, well, that's 320 plus 64, which is $384. Now, my wife, when she thought about it, she looked at me and she said, 324, 60, 384. I'm like, what? She said, 324, 60, 384. And it took me a second, and then I realized, yep, that's right too. 300 plus 24 plus 60 is also 384. We both thought of it very differently, and neither of us thought about it the standard way in which we're taught to do multiplication. Imagine if we would have done this. 32 times 12. And the way that we've been taught to do this on paper is to 2 times 2, which is 4, 2 times 3, which is 6. and then we shift over, put a 0 as a placeholder. 1 times 2, which is 2, and 1 times 3, which is 3. Add them together, and we get 384. That's the standard way in which we were taught. Now, the way that I came up with it is I said 320 plus 64. And you might say, oh, well, you just did it that way. But that's not actually how I thought of it. This is what I thought. 32 times 12. I said, I know that 10 times 32 is 320. And I know that 2 times 32 is 64. Therefore, I get 384. Although the numbers here are the same as the numbers here, the way I thought about getting those numbers is very different than the standard algorithm that we learn in school for how to solve these problems on paper. Neither of them is wrong, and neither of them is more right. They're just different ways of thinking. So what did my wife think of? Well, she had 32 times 12. And she said, that's 300. So she thought 30 times 10, which is 300. Then she said, and 24, she said 2 times 12 gave me the 24. And then she said, and 60, because she thought of 30 times 2, which is 60. When you add them all up, you still get 384. And everything she did is mathematically correct. Just like what I did is mathematically correct. And the way that we were taught is mathematically correct. This is developing flexible thinking. I could have solved it this way, but I probably would have needed a piece of paper. But I needed to think of this in my head. So I had to come up with a way of solving this. And this is how I naturally think when I don't have paper around. Developing flexible thinking is when we are open to thinking about math in a different way. And we start to develop our own strategies to develop efficiency in our own thinking. So when we come across a problem, we have our way of figuring it out. It adds tools to our toolkit. Okay, here's another situation. Sometimes we're asked to subtract numbers, like this problem here, 246 minus 98. Here's the standard way in which we've been taught how to solve a problem like this. We say, 6 take away 8. Well, I can't take 8 away from the 6, so I need to borrow from the 4, making that a 3, and now I have 16. 16 minus 8, which is 8. Now I move to the tens place. 3 take away 9. I can't take 9 away from 3, so I have to borrow from the 2, make it a 1, and put a 1 here. 13 minus 9 is 4, and 1 minus 0 is 1, and I get 148. That is how we use the standard algorithm to solve a subtraction problem like this. But is that the most efficient way? Is that the only way we can solve a problem like that? If we're developing flexible thinking in ourselves and developing flexible thinking in our kids, one of the things that we want to do is, how would we do this in our head? If we just had to solve it without paper, what strategies would we use? What types of things might we do? Well, here's another way of looking at the same problem using a different type of thinking. 246 minus 98. Well, if I understand how numbers work, I know, you know what? 98 is really close to 100. So what if instead I said 246 minus 100? Well, that would give me really quick 146. But I know that I subtracted too many. Too many, so let me add them back in. And I get 148. If I was doing this in my head, that might be a much more efficient way of figuring this out. 246 minus 98 is the same as 246 minus 100, which is 146, plus two more, which is 148. It's a way in which I can think about it without necessarily having to go through all of the standard algorithm. Both mathematically correct, but different ways of thinking about the same problem. This is the last example I want to talk about right now. I was in a room of adults one time, and I was talking about math and talking about flexibility in our thinking, and I simply asked the question, without writing anything down, I want you to do 62 minus 28 in your head really quick. And I gave them, about 10, 15 seconds to think about it. Then I started to ask for hands. How did you solve it? And I started to write down every single way that people solve this. And in that room, we came up with 13 completely different ways of solving that problem. Now, I'm not going to go over all 13 right now, but there was one way that I had never seen before and had never thought about how it connects to the other things that we learn in math that I had to share it. And here's what they said. In my mind, I envision that I have this number line, and I have 28 over here and 62 over here. And I don't know the space in between those. But if I just move 2 over here to 30, and I move 2 over here to 64, I do know the space between those. The space between 30 and 64 is 34. So that means the distance between 28 and 62 has to also be 34. My jaw dropped. I was like, that makes so much sense. They're just using this idea that if I have two numbers on a number line and I shift them around the number line but don't change the space between them, the difference between them stays exactly the same. That was all done in their head quickly, because thinking about the standard way in which we would have solved this can be difficult sometimes to do in our head. Easy to do on paper, not always easy to do in our head. Say 2 minus 8, can't do it. Borrow from the 6, make it a 5, place a 1 here. 12 minus 8 is 4. 5 minus 2 is 3. We still get 34. They're still both mathematically correct, just different ways of thinking. And when we explore ways like this, when we look for alternative ways of solving problems, we start to develop our flexible thinking, which allows us to develop flexible thinking in our kids. One of the best ways of doing that with our kids is to simply ask them, how did you think about that? If you had to do that in your head, what would you do? That starts the wheels turning and starts to get them to see that math is more than just getting answers. It's about understanding, it's about making connections, and it's about developing strategies in ourselves that we can use to solve problems. So my challenge to you, develop your flexible thinking so you can help your kids develop their flexible thinking. My name's Jeff Dean, and I'm Math Dad.